Okay guys, this is the 2013 paper, sample paper, ordinary level, paper 2. Now what we're going to do is we're going to start on question 6 and we're going to answer 6A, right? Explain what is meant by the converse of a term, okay? And what we can say the converse of a term, okay, is a theorem. It's a theorem or an idea obtained by reversing the roles of the premise and conclusion of the initial term. Now, an example would be, it pretty much means the reverse of the term says. An example would be, all squares are parallelograms. Okay, we can see the premise here, and then the conclusion. But we can reverse this around by saying, not all parallelograms are squares. Okay? Statement. Equilateral triangles. The premise are shapes which do have 3 angles. Your conclusion. Converse. Change them around. If a shape has 3 angles, it is an equilateral triangle. So clearly the converse is false. So this is how it works, okay? Now, there are some geometric statements that are true, but have converses which are false. Give one such example, such geometric statement, and also state, the false converse. Okay. So, as I said here, we can go for this one here. Equilateral triangles are shapes which do have 3 angles. So what we can say is a equilateral triangle here. This is an equilateral triangle and it has 3 angles. Converse, if a shape has 3 angles, it's an equilateral triangle. And we know that to be false because it might not necessarily be an equilateral triangle. Scalene triangles, where none of the sides are the same, also have 3 angles. So this is a perfect example of where the converse is wrong, where the original is correct but the converse is false. So that's what we should put down for that one. Okay. And that concludes part B. So that's B part 1, B part 2. So this part is part 1. And this part in here, the converse, is part 2. Okay. Next one. This is question 7. The King of the Hill triathlon race in Kinsale consists of a 750 meter swim, followed by a 20 kilometer cycle, followed by a 5 kilometer run. The questions below are based on data from 224 athletes who completed this triathlon in 2010. Moira has analysed data from the race using statistical software. She has a data file with each competitor's times for each part of the race, along with various other details of the competitors. Moira produces histograms of the times for the 3 events. Here are the histograms. So basically, what we can say is that in the swim, let's look first of all the gap. There's 2 gaps in between 10 and 14. So that means each one will be worth around, each gap is worth 2. So that's going to be 12, 16, 20, 24, 28. Okay, so just remember that. That's what the gaps are there, okay? Now, use the histograms to complete the following sentences, right? Before we do that, just say what the histograms mean. If I was to take this piece of data here, it means in the swim, in between 16 and 18 minutes. Now 16 to 18 is an interval, right? So in between 16 to 18 minutes, there is roughly 70 people. For example, in the run, in between 24 to 26 minutes, there's roughly 65 competitors who finished in between 24 to 26 meters. So that's basically how to use the histogram, okay? The event on average takes longest to complete is there. So we just need to look at the scale here. Alright. The swim at its longest takes 30 minutes, while the cycle takes 58 minutes at its longest, and the run takes 36 at its longest, okay? So what we're going to be looking at is the cycle. Most of the times in the cycle are from 34 to 50 meters, or 50 minutes. Most of the times in the swim are from 14 to 22, and most of the times in the run are from 20 to 28. So basically the cycle is the one that takes the longest, okay? So there's no doubt about that, the cycle, okay? In all three histograms, the times are grouped in intervals of, it's intervals of 2 minutes, okay? Now, the time for the fastest person in the swim was between, so what interval was it? The fastest person is the lowest value in the swim, which is here. Okay, so this is here, so it's in between, somewhere in between 10 to 12 minutes, okay? The median time for the run is approximately, now we have to find out where the median is, okay? So the median is roughly in the center, okay? So what we're going to say is that the middle part is in between 24 to 26, okay? So the median would be probably located in here in the middle of the diagram where all the most of the data is contained. Okay, we see it sort of has a symmetrical function, and usually the median and the mode's most common value aren't separated that much. Okay, so what we can say is that it's 24 to 26. Okay, but it wants an approximate time, so just get the average of the two of these. 24 plus 26 divided by 2, and we'll give that 25 minutes, okay? Now, about this last question as well, see the area of each one, this represents how many people there is, okay? So, what you could also do is you could add up, you could make a rough estimate of all the people, alright? So you already know how many people there is. There's 224 athletes, okay? So 224 athletes, you can divide this by 2, and what you'll get is 224 divided by 2, you get 112. So I mean it'll be the average of the 112th and 113th competitor, okay? So you gotta find out where the 112th and 113th competitor is. So what you could do is you could roughly put numbers on these. That could be 15, this one here could be 25, this one here could be around 48, this one here is roughly, let's say, 3 people, and this one here is about 65 people, okay? And let's see where the location of the 112th and 113th person is, okay? So add the first 2 together, add the first 3 together, in fact, 5 plus 15 plus 25. What we get there is 45, okay? So there's 45 people in the first 3 bars. Okay, 45 plus 48 is 93. So there's 93 people in the first 4 bars. So there's 93 people here. And then what's going to happen is when you add 93 plus 165, 112 and 113, they're going to be located in here. But because we don't know, we only know it's between 24 to 26, we just get the average of that and say it's 25, okay? The event in which the times are most spread out is there. Now, the times are most spread out, so that means the top value minus the bottom value. Okay? So let's see what we can do here. Top value minus the bottom value. So, swim, it's roughly 30 minus 10. So we're looking for the ranges. This is 20. This one here is 30 minus 60 minus 30. Because 30 is the smallest value, 60 is the highest value, and that's 30. And then in the run, it's 16 to 38. So 38 minus 16 is going to be 22. So the cycle is the one with the most spread out results. Okay, next one. Moira is interested between the relationship between the athlete's performance in the run and in the cycle. She produces the following scatter diagram. Now, what you sometimes got to remember about these scatter diagrams is you usually have a line of best fit that goes in between most of the data. It has to cut it in half, all the dots, so it's around here somewhere. Okay, so just keep that in mind and look at how close the dots are to it. Okay. The correlation coefficient between the times for these two events is one of the numbers below. Write a letter that corresponds to the correct answer in the box. Okay. So the correct answer, if it was A, okay, the first thing you need to know is that basically the negative answers can be ruled out, because the negative answers are all going in the wrong direction. Okay, so negative answers are in the wrong direction. Okay, so we can rule out the negative answers. So that means we're stuck with the 3 positive answers. Okay, if it was 0.13, what would happen is when you have your graph here, so we'll rule out 0.13, and the reason why we're ruling out 0.13 is because all the dots would be scattered all over the place and there'd be no general trend for 0.13. So 0.13 is out. Now we have a choice between 0.95 and 0.77. Look back at the top. 0.95 would be close to perfect. Okay, so if I was to have a line for 0.95, it would look something like this. It would be very close to perfect. Okay, so this is a line, and if it was 0.95, it might look something like this. You'll see that all the points are very close to the line or on the line. Okay, while if it's 0.77, you have lots of dots, more dots off the line. So the answer for this question is B, 0.77. Frank was the slowest person in the run. Slowest person in the run. How many people took longer to complete the cycle than Frank did? Now, if he's the slowest person in the run, what we gotta do is we gotta look for the run figures. Okay. Now the run figures is how high or low we are. So the run figures is here. Okay. And Frank, as you said, is the slowest person in the run, which means he has the highest time. And we can see here the location of Frank. Frank got roughly, let's say, 37 minutes on the run. Okay. Now we have to figure out how many people have a slower, took longer to complete the cycle than Frank did. So what we can do is we can just draw a line, really thin line, all the way down from Frank in a straight line. Okay. And we're just going to count how many of them have a slower time than Frank. 1, 2, 3, 4, 5, 6. Okay. Now I think 6 people have a slower time than Frank. Now there is one person that's on the line here. He could have had a slower time, but it's not obviously slower. So 6 or 7, you could have 2 answers, but I'm going to go with 6. Alright. Brian did not enter this race. Suppose he had, and suppose that he completed the cycle in 52 minutes and the run in 18 minutes. Explain why this performance would be very unusual. Okay, so 52 and 18. Now a run of 18 will put him here, and a cycle of 52 would put him here. So you can see that this is where Frank, this is where, what would his name, Brian's results would be. Okay, so Brian would be up here in this red zone, right? So this here is Brian. Now what's unusual about Brian is we can see that he's miles away from where everybody else is. It's unusual for a person who's fit to have such a fast running time, one of the best running times there is, but one of the slowest cycle times there is. Okay. So explain what this. Suppose he had. Explain what this performance would be very unusual. It would be very unusual. Very unusual according to the results. On the graph to have such one of the fastest one of the fastest run times, one of the fastest run times and one of the slowest a slow cycling time. Now, what we sometimes refer to this anomaly in the data is, you can see how far is away. We sometimes call these outliers. It's just basically inaccuracies. Okay, so it could have been due to an injury or something like that, so we can call this an outlier. Okay. Now, part 3. Moira knows already that the male athletes tend to be slightly faster than the female athletes. She also knows that the athletes can get slower as they get older. She thinks that male athletes in their 40s might be about the same as female athletes in their 30s. She decides to draw a back-to-back stem and leaf diagram of the times for these two groups for the swim. So the swimming event only. There were 28 females in their 30s and 32 males in their 40s. Here is the diagram. Okay, so let's have a look at the female distribution. Okay, so what we could just do is have it come up like so, and we can see that the females peak here, the male distribution stops here. So we can see straight away that the female distribution is much more spread out. A slowest time of 265 and a fastest time of 134. While in the male event it's 149 being the fastest time and 230 being the slowest time in minutes. Okay. Oh, sorry, 26.5 minutes. Excuse me. You got to read the key. So that's 13.4 minutes. So 13.4 minutes being the fastest time, 26.5 minutes being the slowest time, and in the male event 14.9 minutes being the fastest time and 23 minutes being the slowest. Okay, so let's see what questions. Describe what difference, if any, there are between the two distributions above. The female distribution is more spread out. With a range of, so to back up your word you need to find the range. So 13.4, 26.5 minus 13.4 gives you 13.1 minutes. So with a range of 13.1 minutes. In comparison to the males, once again just 23 minus 14.9. Now what we're going to get is 0.1 carry the 5, 8.1 minutes for the men. Males range of 8.1 minutes. Okay, Moira drew the diagram because she thought that these two groups would be about the same. Do you think that the diagram would cause Moira to confirm her belief or change her belief? Give a reason for the answer. What we can say is that the shapes are more or less the same, and we can say that the majority of the competitors, which is the majority of the competitors for the men, and the majority of the competitors for the women, are located in the same interval of 15 to 21 minutes. Do you think that diagram should cause Moira to confirm her belief or change it? Confirm her belief. Belief as the majority of male and female competitors finish the swim in the interval of 15 to 21 minutes. Well, it's actually 15 to 22 minutes because we're not actually including the 22. 22 is the cut-off point, so 15 to 22 minutes. Okay. Next question. Okay, this is question 8. A stand has been used to prop up a portable solar panel. It consists of a support that is hinged onto a panel near the top and an adjustable strap joining the panel to the support near the bottom. By adjusting the length of the strap, the angle between the panel and the ground can be changed. The dimensions are as follows. Okay, so AB is 30 centimeters. A to D, I think we'll need to make this a bit smaller. Okay, AD, which is here, equal to CB, which is 5 centimeters. CF, which is here to here, is going to be 22 centimeters. So we're just going to start filling in some of our measurements here. Okay, so that's going to be 22 centimeters. This one here be 5 centimeters. This one here is going to be 5 centimeters. And then we got A all the way to B is 30 centimeters. So if A all the way to B is 30 centimeters, like so, it will make this area in here from D all the way up to that one, it will make it 20 centimeters. Okay? So 20 centimeters for this blue part here, because it's 30 minus 10, which is going to be 20 centimeters here. Okay? So now we got 20 and 22. And no word about E to F is 4 centimeters, which is this part here. And then what we can say about this 22 is you can also say from here to here is 18 centimeters. Okay. The two diagrams are, we want to find out how long the strap has to be in order to make an angle alpha between the panel and the ground equal to 60 degrees. Okay. So let's look at the two triangles, okay? And what we can say about the first one is that from A to C, so we're going from A all the way up to C, that's 5 plus 20, okay? And C, if we can see it here, C is located here, so C stops here. It's 20 plus 5 is 25. So we know that this length here is going to be 25 from here all the way up to there, okay? Next one. We got to find the length of C to F, and we already know the length of C to F is the full 22. C to F is 22, so we know this here is 22 centimeters, okay? Now the two diagrams given below showing one triangle CAF and the other showing CDE. Use the measurements above to record on the two diagrams below the lengths of the two of the sides in each triangle. There's 1 and 2. Now we got to get C to D, okay? And what C to D is, it's going to be 20 because we sorted that already. C is here, D is down here, and what we said it's 20 from earlier because it's 30 minus 5 minus 5. 30 minus the 2 5s, so it's going to be 20. And CE is going to be 18 because remember what we said earlier, it's not 22, it's 22 minus 4, which is 18. Okay, so now we have here, this is 18. Okay. Now next question. Okay. Taking alpha equals 60 degrees as shown, use the triangle CAF to try to find the angle CFA correct to 1 decimal place. So use the triangle CAF. So this one here is CAF. We're looking to find the triangle angle CFA. So CFA, let's call it X. Now, what we can use here is the sine rule. The reason we can use the sine rule is we have an angle and two sides, okay? And it's the angle isn't in between the two sides. So if the angle was in between the two sides that we're using, we'd have to use the cosine rule. But because the angle we know isn't sandwiched between the two sides we know, we're going to use the sine rule. So we're going to get sine X divided by whatever side is opposite to the angle X. It's going to be 25. Divided equals 22 divided by sine 60. Bring 25 over the other side, and what we're going to get is sine X equals, oops, excuse me guys, just did this one upside down. Okay, so it's sine X over 25 equals sine 60 over 22. Excuse me. We want to get sine X on its own. Cross multiply, so sine X equals 25 sine 60 all over 22. And what we can get here is sine X equals 0.984. And what we need to do next is separate sine and X. You need to use sine inverse to find out what angle X is. So sine inverse 0.984. And X is going to be equal to sine inverse 0.984. And what we're going to get is 79.737 degrees. Okay? So the angle CFA equals 79.737 degrees. Now let's see, doesn't want it rounded off. Correct to one decimal place. Very important to remember that. So it wants it correct to one decimal place. It's going to be 79. Change that to 737. We'll go to 700. Take away the 2 zeros. 79.7 degrees. Okay. Now, what can sometimes happen is the answer in that batted book is actually 79.8. So sometimes what you have to remember is when you're doing these questions is you got to put in maybe more decimal places. So if you were to put X equals sine inverse 0.9841198. So that would be if you're using more decimal places. Let's see what X comes out to this time. So sine inverse 0.984.1198, and this time it comes out as 79 degrees 0.7755, and this will round off to 79.8 degrees. So just be wary about how many decimal places you use. Sometimes 3 isn't enough, maybe you should go 4 or 5 just to make sure, okay? Now, next question. Hence find the angle ACF correct to one decimal place. So let's find out where ACF is located. A to C to F. ACF. So to find ACF, all we're going to need to do is 180 degrees. So this time we're looking for ACF. It's going to be 180 degrees minus 60 minus 79.8. So into the calculator with 180 minus 60 minus 79.8, and what we should get is 40.2. So it's going to be 40.2 degrees, okay? So we can just write that down here, 40.2 degrees, because it's 180 minus 60 minus 79.8 degrees. Use the triangle CDE to find DE, the length of the strap, correct to one decimal place. Let's call DE the letter Y. We go back here. Now, we know this is 40.2. We also know this is 40.2. Okay, and now we have to find DE. which is the length of the strap. So the length of DE, we're going to call it Y. Now, in this question, what we have is what I was describing earlier. We have the angle in between two sides. Okay, and this here is 40.2 degrees. It's an indication that you're going to use the cosine rule. So what we're going to do next is write out the cosine rule and attempt to use it. Okay. So what we're going to get for the cosine rule is the following. We're looking for y. And because we're looking for y, we got to use the angle that's opposite y. So when you look up the cosine rule, this is what you're going to see. B squared plus c squared minus 2bc cos a. Now, cos a is going to be cos 40, because that's the angle you're using. What's opposite of 40? If 40 is big A, what's opposite to 40 is small a. So small a is y squared. B squared and c squared are interchangeable. Let b squared be 20 squared, c squared be 18 squared, minus 2 times 20 times 18. And all we got to do now is y squared equals, just place all of this directly into the calculator. Okay, so we'll get 20 squared plus 18 squared minus 2 times 20 times 18 cos 40. And what we're going to get is 172.448 square root it. So press the square root button on your calculator to find out what y is. Root. And what we're going to get is 13.132. Look up to see how far we need to round it up. We need to round it off to 1 decimal place. So we go back down here to 1 decimal place. Y is going to be 13.1 centimeters. Okay. Now, once again, we made a quick mistake there. I used cos 40. I meant to be using 40.2. So that's introduced a slight error into my question. So make sure you don't round off. So we're going to try this again, except this time we're going to use the 40.2. Cos 40.2. And that's going to, instead of that, it's going to actually get us 174. 174.067. Square root that in the calculator. And what we're going to get was 13.19. This rounds off to 13.2. So just be careful about including decimals in the question. As we can see, it leads to errors if we don't put in all our decimals. Okay. Next one. So that is all of that question answered. It's 13.2 centimeters. Okay. And that is everything there. So next question, question 9. The diagram below is a scale drawn of a hopper tank used to store grain. An estimate is needed of the capacity volume of the tank. The figure of the man standing beside the tank allows the scale of the drawn to be estimated. So here's the figure of the man beside the tank. And what we got to do is we got to figure out what is the size of the tank, and therefore what is the volume of the tank. Okay. Now, what's basically uncommon about this question is you need to know a bit of general knowledge about average male heights. And the average male height is around 1.78 meters, okay? So it's 1.78 meters. So you just had to average it around 5'10", 5 foot 10 through 6 foot, 1.78 meters, okay? Now we can see that he's 6 blocks high. So 1, 2, 3, 4, 5, 6. So 6 blocks equals 1.78 meters, okay? So 6 blocks equals 1.78 meters, okay? So what we're going to use is the average man being 1.78 meters. Using your answer to part A, estimate the dimensions of the hopper tank. Write your answers in the spaces provided on the diagram. So what we can say next is that one block, what we're going to do is we're going to divide 1.78 by 6. So divide it by 6, and we can see how much one block is worth. And what we're going to find out is 0.2967. Okay, and what we do is we'll round it off to 0.3 meters. Okay, now each one is worth 0.3. So what we got to do next is just got to count our blocks and multiply them. Okay, now this one here, what I've also decided to do was I've decided to basically use my ruler as well. 1 centimeter is 2 blocks, so what I can do is I can measure out this in centimeters. Okay, so I can say that 1 centimeter equals 2 blocks, and 2 blocks equals 0.6 meters. So what I can do now is I can just put it on my dimensions. Okay, so this one here is going to be from line to line is going to be, let's call it 1.5. Okay, so 1.5 multiplied by 0.6. So 1.5 multiplied by 0.6 into the calculator. And I'm going to get 0.9 meters for this one here. Next one, I'm going to count this one in centimeters as well. I'm going to get 4.6 centimeters. So 4.6 centimeters is going to get multiplied by 0.6 again, because it's 4.6 centimeters and that's worth 0.6. So 4.6 multiplied by 0.6, and what we get is 2.76 meters for that one. Then we're going to go down to the third one, and I am going to get 2.7 centimeters. I'm going to multiply 2.7 centimeters by 0.6, because each centimeter is worth 0.6 of a meter in real life. And what I'm going to get here is 2.7 multiplied by 0.6. I'm going to get 1.62 meters for that one there. Okay. Okay, and finally, what I need to do next is I need to get a hold of the horizontal line at the top. The horizontal line at the top is going to be 4.2 centimeters. So 4.2 centimeters multiplied by 0.6, and what that's going to get me is 4.2 multiplied by 0.6, and that's going to get me 2.52 meters. Now that I have all these workings done, I'm just going to rub them out. Now remember to keep your workings included on the on basically the box. Okay. Now what we're told next is the tank, taking the tank to be a cylinder with a cone above and below, find an estimate for the capacity of the tank in cubic meters. Okay. So what's happening here is we have two shapes. Okay. So we first of all need to get the this one's a cone, the bottom one's a cone, and the middle one's a cylinder. So we need to find out what the volume of a cone is. The formula for the volume of a cone is 1/3 pi r squared h. Okay. So what we're going to do is we're going to find cone A and cone C. Okay. So volume of cone A. So what we can say is that it's 1/3 pi. Now what's the radius of this? The radius is going to be half of 2.52. So we got to get half of 2.52, which is around here. So half of 2.52 is going to be 1.26 meters. Okay, so it's going to be 1/3 pi 1.26 squared multiplied by h, which is 0.9. Put this into the calculator, and I should get and what I get is 1.496277. Okay, so 78 at the end. Okay, so 128. So if we're just to do that, we just rub that out and make it 28. Now just do it to about 5 decimal places at the start. It's going to be meters squared. Now that's cone A. Now we got to do cone B. And we'll do cone B in different colour here. So cone B, we'll do it in green writing. And cone B is going to be a third pi. It has the same radius as cone A, so it's going to be 1.26 squared. And then its height is going to be 1.62, so it's a bigger cone than cone A. Put that into the calculator. And what we should get is, we will get 2.693. Now 5 decimal places, what we'll be looking for? 33. Okay, so we'll just put the 4 decimal places, okay? And that's going to be meters squared. Now finally, we got to get the formula for a cylinder, because the middle part is a cylinder, like a Coke can. So the top and bottom were 2 cones, like so. But the middle is a cylinder. Okay? So the formula for a cylinder is pi r squared h. Okay, so cylinder B is going to be pi r squared h. So it's going to be pi. Once again, it has the same radius as the cones. So pi times 1.26 squared times the height, which is 2.76. Just going to multiply that all together. Okay, so 1.26 squared multiplied with 2.76. Now the cylinder should be the biggest, the one with the biggest volume. So that you can see that the cylinder has 13.76 76576. Okay, meters squared. Now to get the total, we need to add up all 3 answers together. Okay, so we're just going to rub this out, and now we're going to add up all 3 answers together to get the total of the total volume. Okay, so total volume would therefore equal 1.49628 plus 2.6933 plus 13.76576. So we're just going to add them all together. 1.49628 plus 2.6933 plus 13.76576. And what we're going to get is 17.95 meters cubed. Okay, because it's actually not meters squared, it's meters cubed because it's a volume. Okay, so excuse me, it's meters cubed. Okay, so calculate the capacity of the tank in cubic meters. Okay, so what I got for that was 17.65 cubic meters. So 17.955 meters cubed. Now remember, it's an estimate, so everybody will have different answers for this question, okay? So don't be worried if you didn't get the same answer. Okay, that concludes the end of this video.